So thinking about wanting to see what's going on in math, those conversations that are happening in the Math Rural Connects, what happened in the math summer session, a lot of the focus has been around not just instructional strategies that we're using, and a lot of those instructional strategies are the same for teachers, whether they're in the science cohort or in the ELA cohorts or in the math cohort. But we're also really diving into a lot of mathematical strategies. And for math teachers, we've talked about how important it is that math teachers have this wide range of strategies that they can use to access for both instruction or when they're supporting students in small groups, that they're able to kind of find the exact strategy that matches the benchmark, the level of rigor needed, and the specific student. Thinking about your lens as admin and coaches, the requirements are a little different. As an admin or as a coach walking into a classroom, you don't necessarily need that same toolkit of mathematical strategies. However, I do think it's important that as an admin or a coach, you can walk into a classroom and very quickly assess, is what we're working on at the right rigor in a couple of ways. One of those ways is, are we working on the right numerical ranges? Like, are the numbers I'm seeing the right kind of numbers? And then also, are the strategies I'm seeing the right kind of strategies based on what the numbers are, based on what the progression is as we work from kindergarten on up through 5th grade. And you don't necessarily need to have mastered all of those strategies yourselves. And so as we go through a couple of items, we're going to look at some mathematical items. Some of these are from released items. Some of these are from the Big M. Some of these I just made up myself. I'm going to have you try to figure out what grade level and what strand it came from. But there's a couple of things that I want you to really attend to and a couple of questions that I want you to answer so that you can have this takeaway. So the first, of course, being, right, what grade level does this fit in? And I'm going to give you a hint. Almost every question, it has to do with the numerical range. Like, where do the numbers fit in based on what we're trying to do with the numbers? Are we adding them? Are we multiplying them? Are we comparing them? Are we dividing them? And then based on those operations or the skill we're doing, where do those ranges fit? Does that fit in 3rd grade? Does it fit in 4th grade? And then the second thing that I want you to try to attend to is, what are the instructional implications for that? There's a reason that our benchmarks build systematically in the way they do. The things that we do with fractions in 3rd grade and the limitations around fractions in 3rd grade are there so that we can build understanding, not just get answers. And then it gets a little more rigorous in 4th grade and that changes. So as we're going through, I'm going to show you the item. I want you to look for what grade level do you think it is and what strand do you think it comes from. But I also want you to think, why is it not the grade level below? Why is it not the grade level above? So for example, if you think the question I show you is 4th grade, why is it not 3rd grade? What would have to change to make it 3rd grade? If you think it's 4th grade, why is it not 5th grade? What would have to change to make it 5th grade? And then based on that little slice that it sits in and that big systematic progression across all the grade levels, what are those instructional implications? And we'll kind of have that conversation around each of these items. And what I want you to take away is kind of an understanding of, you know, I haven't mastered the knowledge of all of these benchmarks. I can't walk in and say, oh, they're working on this benchmark immediately. But I do want you to be able to walk into a classroom and answer the question, are they working on the right numbers? Are they working with the right numerical ranges? Are they using strategies that fit the intent of sort of the benchmarks as a whole? Does that kind of make sense? All right, and we'll figure it out. The first couple might be kind of slow. As we build our knowledge, as you start to see where these things fall, I think we'll start to be able to go a little bit faster as we go through. So just real quick, a couple reminders. What are the strands? Because remember, I'm asking you for the grade level and the strand. And so here's your options. We have the number sense and operations, fractional reasoning, algebraic reasoning, measurement, geometric reasoning, data analysis, and probability. That list is also in the standards book if you need to look at that list to help you. It's in sort of the front matter in the first couple of pages. So that's the strands, that's the options. You'll be looking anywhere from 2nd to 6th grade. So the math cohort is 3-5, but I don't want to make it too easy. So 2nd grade to 6th grade is where all of the items you're going to see fall. So here's our first item. What I want you looking for, what grade level and what strand. That's what I'm going to ask for. Use your standards book to verify your thinking, but I do want you to have a little conversation first. Where do you think it falls? And remember, why does it fall there? Why is it not the grade level below? Why is it not the grade level above? And what are the instructional implications? Do y'all have any hunches right at the beginning? Anything you're thinking? Well, just keep looking this way. Just keep looking this way. So any thoughts right away? What grade level you think it might be?
I said fourth.
Fourth? All right. Why are you thinking fourth?
Because I've walked in their classrooms and seen them doing their fractions.
Okay, so you've seen fractions in fourth. We have fractions, so maybe fourth. Okay.
See third grade.
Okay, so there's fractions in third as well. So there are fractions in both third and fourth. So where does this one fit? Yeah, they start partitioning and doing things that are sort of fraction light. They start using that language of halves and thirds and quarters as early as first grade. Mm-hmm. So somewhere in there, somewhere between first and fourth, we're narrowing in.
Wait, my sea palms are coming up here.
Oh, you want a keyword search? There you go. So I'm seeing third grade.
But that's down here. That's equivalent fractions. This is ordering and comparing fractions.
So what are we doing with the fractions in this problem?
You're ordering them.
So ordering, comparing, okay.
Comparing.
So that's definitely a third grade.
Okay. So that skill also happens in fourth grade. So if we're thinking third grade, why would this be third grade and not fourth grade?
Because of the limitations, clarification 3. Fourth grade.
Which is what? Specifically what?
The denominators of 2, 3, 4, 5, 6.
But they're doing it with
12.
decimals in fourth. They're also comparing
Okay.
relationship between fractions
Yeah.
and decimals.
There's also something about these fractions that is really important.
They're greater than whole. Some of them have to be.
Okay.
The numerators are all the same.
The numerators are all the same. Okay. Is there any language around that in either the third or fourth grade benchmarks? So as a third grade teacher, if I know I'm going to have common numerators or common denominators, how do I approach that instructionally? Like, what does that tell me I'm trying to get my students to understand, how they're going to try to answer these questions?
So I don't want to say go back to second grade standards, but first they got to understand the really what a numerator is, what a denominator is.
Okay.
Then, building on that skill, which they already should have learned in second grade.
Yeah.
And then just really learn the idea of ordering, and then ordering based on numerators, ordering based on denominators.
Gotcha. So it's really supporting that understanding of what is a numerator, what does it mean, what is a denominator, what does it mean. Gotcha. All right, so what grade level are we thinking here? What grade level? Third grade. And what strand? Fractions. Yeah, it made it kind of easy. They're all fractions, right? Does anyone have this specific benchmark, all the way down to the benchmark? 2-1, FR 2-1, it's tiny font there, but yeah, third grade fractions 2-1. So what are we doing with the fractions in this item? Comparing, ordering. That skill also happens in fourth grade. So why is this not fourth grade?
Because the numerators are the same.
Numerators are the same. So Bridget just said it's third grade, not fourth grade, because the numerators are the same. Which is right. In fourth grade, they're going to be comparing without common numerators or without common denominators. I want y'all to think, what are the instructional implications for that? So like as a third grade teacher, if I know that my students are going to be dealing only with common numerators, common denominators, what does that mean instructionally? What approaches should I take? What strategies am I thinking about? How am I talking about it? How am I teaching students to think and answer these questions? What are some of the things y'all talked about already?
For me, with same numerator or same denominator, I'm thinking a lot more of like visual, the size of things.
Okay.
Because if the denominator is all the same, you'll either have different quantities of that size. If the numerator is the same, the size of those pieces will be different. So like I feel like coming from fourth grade with that, like whereas it's more of the computation of fractions, this can be a lot more visual in size proportion.
Gotcha. So as an admin or a coach walking in, I see students working to compare fractions. I'm thinking like, I need to see some visuals, maybe manipulatives or pictures, something that's really cementing the idea of what a numerator means and how the numerator tells me something about its size. What a denominator means, how it tells me something about its size. I don't necessarily need to be using anything algorithmic or anything that's heavy in computation, because it's all common numerators or all common denominators. That's not a necessary strategy yet. We can still be efficient because we have that limitation and build understanding at the same time. So kind of thinking about that, right? Putting that in your brain. You go into a third grade classroom, we're comparing and ordering fractions. We want to be thinking, hey, they should have common numerators or denominators, and really leaning on the understanding of the size of the pieces and how the numerator informs that, how the denominator informs that. I don't necessarily want to see a lot of computation heavy, algorithmic heavy things, because that's going to take away from building that understanding. All right. So that's kind of what I'm looking for in the conversation. I gave you a little longer for that one, so just expect the next question. I might go a little bit faster. But those are the things I'm looking for, right? The grade level, the strand. Let's narrow down to the benchmark if we can. What makes it that specific grade level? And then what are the instructional implications? As an admin or a coach, when I walk in, what should I anticipate to see if I see they're working with those types of numbers in that grade level? All right, so here's our next question. I'll give you a second to read it, and then start those conversations. What grade level? What strand? Why is it not another grade level? What are the instructional considerations? So what are we doing with the fractions in this?
Subtraction.
Okay, so we're subtracting. All right, so we have different than comparing. So we're in operation now. All right, so we're adding or subtracting. And what do you notice about the fractions?
Denominators and numerators are different.
Okay, denominators are different, numerators are different. Okay, so kind of helps you know what you're looking for now. Once you have found the benchmark, once you've found the grade level, make sure you're talking about those instructional implications. What does it mean for that grade level? What kind of strategies are going to be important? What kind of strategies aren't as important? So there's also a benchmark in 4th grade around operating with fractions. So why is it the 5th grade and not the 4th grade?
Because the numerator, or not numerator, the denominators are different. Like this one.
The denominator is different. In 4th grade, is it always limited to common denominators in 4th grade?
With like denominators.
Okay. Okay.
I feel like he's doing a teacher thing, like you need to re-look at what
No, maybe I am, maybe I'm not.
In the language that makes
Yeah. So thinking about 5th grade then, what kinds of things do I need to be thinking about instructionally, knowing that we're dealing with unlike denominators?
helping. I don't know the math lingo. What is it? You come to an ELA table.
Remember, I've already said if I died and went to hell, my math teacher from high school.
I'm not your math teacher from high school,
Her name was
though.
Lanita McGill. She was a great person, a great teacher. And she's not going to be in hell, but she'll be with me with rats.
A common denominator. All right, we need common denominators. Yeah, which means we need to be thinking about equivalent fractions as well, right?
Shanna would be proud.
Okay. All right. What grade level are we thinking here? What grade level? Let's see, 5. Yeah, 5th grade. All right, 5th grade. What about the strand? It's fractions again. Yeah, and did anyone get the exact benchmark? 2.1. Yeah, 5 FR 2.1. So we're doing something different now. We're not comparing anymore. We're doing some operations. We're in the world of addition and subtraction. And what do you notice about these fractions specifically? Different denominators. So there's also a benchmark in 4th grade for adding and subtracting fractions. So why is this one not 4th grade? 4th grade is common denominator. We already have that. So as a 5th grade teacher, what's important here? What instructional strategies, what other ideas, what things matter to me as a 5th grade teacher dealing with addition and subtraction of fractions that don't have common denominators? Multiples, okay.
In 4th grade, the factors only went up to 12.
Okay.
In 5th grade, they can be anything.
Okay, so our factors change as well, which thinking 4th grade, I don't need to find common denominators, so I'm not, there's another benchmark where I'm dealing with equivalent fractions in 4th grade as well, but specific to the operations. I don't need it, but now I do. All right, now I do need that. All right, what else? Anything else? I don't want to imply there is. I just want to open up to ideas.
Equivalent fractions.
Okay.
Greatest common denominator.
Gotcha. So I'm thinking more about equivalent fractions. It's kind of letting me know that if I'm just dealing with this in isolation, we might be struggling. I've got to also be talking about equivalent fractions, finding equivalent fractions, because I need something that has a common denominator, which is going to be an equivalent fraction to whatever it might be, right? All right, here we go. You ready for the next one? All right, so here's our next one. I got a theme going on here, if you can't tell. Hopefully a previous conversation helped guide you to this a little more efficiently. All right, so I see fourth grade. Did y'all kind of quickly go to fourth grade? Is that what you were thinking at first?
We went to fourth, but then we flipped back to third to verify.
Okay.
Went back to fourth.
So why did you start with fourth?
Different, yeah.
Oh, and what are we doing with these fractions?
We're ordering them.
We're comparing, we're ordering them. We already had the conversation about third grade, but what's different now?
The numerators are all different.
Different numerators and denominators. Okay. So instructionally, how do I have to think about this differently as a fourth grade teacher compared to the third grade teacher?
We're looking at equivalent fractions.
Okay. Yeah, comparing without like numerators, without like denominators, without something that helps me visualize their size, I'm going to need an equivalent fraction. And in third grade, if we've spent that time really thinking about what numerators and denominators mean and how they impact each other, it's only going to make that ability to look at a fraction and quickly go, it's less than a half, it's more than a half, it's less than a quarter, it's more than a quarter. It's really hard to do that if in third grade we just started computing and we didn't start trying to build reasoning around those pieces. Yeah. All right, what grade level are we thinking now? What grade level? Fourth grade. And I'm just going to jump right to this question because I heard some really good conversations. Why is this fourth grade? It's really similar to something else we've already done. Why, Kevin, why is it fourth grade?
Because you're ordering different numerators and different denominators.
Gotcha. We're ordering like we were in the third grade example, but now we have different numerators, different denominators.
So in the clarification of the three, the denominators are limited to 2, 3, 4, 5, 6, 8, 10, 12, and 16, and 100, and there's a 9.
Oh, there is a 9. There is a 9. So I'll tell you where I got this from, and then you can send that email. This is a screenshot out of the Big M, which is a living document. It's one of the things that I love about the shifts we've made. If you email them and say, hey, I found this, it's out of the limits, they'll fix it. They will fix it. So you now get to send that email. You now get to send that email. All right, so it is fourth grade. We are comparing like we were in third, but now we don't have these common numerators and denominators. What are some of the instructional implications for that? As a fourth grade teacher, what do I have to think about that might be a little different than the third grade teacher who always has like numerators or always has like denominators? We had a good conversation back there. What's something y'all talked about? Yeah, so now I'm thinking about equivalent fractions. I might need some equivalent fractions, okay? So now we're like maybe doing some computing. I wasn't really computing in third grade. I was reasoning about their size based on the numerators and denominators. All right, what else? There's other ways to think about it. Wyatt, we had a pretty good conversation. What were you thinking? What did you hone in on?
In third grade, they're either because of the same numerator denominator or because of the computation behind it, they're taught like a certain computation skill for it. Whereas in fourth grade, one of the clarifications about using benchmark fractions starts to take the reasoning towards that higher level thinking of, in their minds, comparing these to a half or one whole. So starting to get into more of like, I don't know how, other than abstract thing, like just thinking of it as relative to other.
Yeah. I know 3/5 is more than a half. I know 1/4 is less than a half. Those don't have common numerators or denominators, but I know 1/4 is less than 3/5. I know 3/5 is greater because of how they're related to a half. So that's some of the reasoning we want to think about. And part of the conversation that we had was it's really tough to think about fractions in that way if in third grade We didn't spend a lot of time reasoning with those numerators and denominators. In third grade, if we just jumped right to computation when it wasn't quite necessary yet, we're not going to develop that understanding of what the numerator tells us and what the denominator tells us and what those sizes look like and how those sizes compare. In fourth grade, we might need to do some of that. Like sometimes that kind of reasoning isn't going to work. Like 2/10 is less than a half. 1/3, like all of these are less than a half. And so if I'm really comfortable thinking about less than a half, more than a half, maybe I need something else. But it does sort of open up the thinking and the strategies I might need around that in fourth grade. All right, so if I walk into a fourth grade classroom and we're comparing fractions, I don't want to see a lot of common numerators and denominators because that's not the ranges that we're working with. That's not the ranges of numbers that they're going to see on FAST, and that has implications for the strategies we use and how we talk about it. All right, so here we go. And I think this is my last fraction one. I'm going to give you two that are out of fraction world after this one. So this one is a little tricky. I'm going to ask you to focus on the most complex part of this question. If we broke that apart by A, B, C, and D, it actually might fall into a few different grade levels. So I want you to try to focus on the most complex part of this question. What grade level does that fall into? So what are we doing with the fractions?
Multiplying.
Okay.
But then we're describing.
We're trying to justify,
Yeah.
Okay.
Reasoning. Oh gosh.
So what do you notice about the fractions?
That they have different denominators.
Okay, different denominators.
Okay, you're talking about
Can you
the
imagine
fractions
if
in
you
that
had
thing?
you know what, this is like your very first Rural Connect with brand new teachers that are not math education, and you're talking
And the one
about
time we're trying to fill in for
we
Shannon.
are.
So there are two places multiplication of fractions falls.
Okay.
Fourth grade
And multiplication.
and fifth grade. Which one of these and why does it fall in there? All right, so we have fractions, obviously, right? What are we doing with the fractions? We're multiplying. So there are two places that multiplication of fractions falls. There's a benchmark in fourth grade and there's a benchmark in fifth grade. Which grade does this one fall into? I see some fives. I don't see any fours. I don't see a lot of fives, but I see some fives, but I don't see any fours. All right, so if you're holding up a 5, why is it fifth grade, not fourth grade?
It's more than one, you're multiplying by more than one numbers.
More than one. All right, so that's kind of part of it. It is more than one. Ooh, say that again.
It says that it's multiplied by a whole number.
In which grade level?
Fourth grade.
So in fourth grade, we have a fraction times a whole number. So we have two numbers represented as fractions here, which make this fifth grade. All right. Now, depending on how we are thinking through or reasoning this, there's actually a couple of benchmarks, and kind of what I was mentioning. Like, I want you to try to think about the more complex thing that's happening here. But I'll go ahead and give you both benchmarks that this could fall into. 5FR22 or FR23. One of them is more focused on just the procedural reliability of getting the product. One focuses a little bit more on the reasoning, which is actually what's happening here in A, B, C, and D. Like, I could just answer this question, and that would kind of directly only fall in FR22. Because this reasoning is happening, that's why I'm also thinking about FR23. FR23, what are some of the instructional implications? What are things I need to be thinking about as a fifth grade teacher with this? Like, I could imagine a lot of students that could give me the product to this and not get this question right. So what are the instructional implications that we want to think about here as a fifth grade teacher?
Assessing reasonable answers.
All right, so thinking about reasonable answers, and how do we do that? Like, let's talk about the math. Like, how do we do that?
Start from their basic comparing and contrasting on how they saw what a fraction looks like in there.
Okay.
And then comparing it and explaining relative size of it.
So there's some comparing and some contrasting, some relative size. What let's think about this for a second and just kind of do the math. 3/8 times 6/5. What's important about 6/5? It's greater than 1. And what do I need to know as a learner? What do I need to know? What's important about that? My answer, not necessarily more than 1, but it's going to be more than 3/8. Right? If it was 5/6, if it was less than 1, my answer would be smaller than I started, which is kind of a weird idea. Now, we're multiplying and the answer gets smaller. Or sometimes we're multiplying by fractions and the answer still gets larger. Right? It just depends on how it's compared to 1. And if I'm not having those conversations, I'm not using strategies that are really helping develop that idea around, again, it kind of all goes back to like what the parts of a fraction mean, and how they work together and how they kind of play off of each other. And then when we start operating with them, how that works. And just think to the conversations we've had about 3rd grade and we've had about 4th grade and how those things would really help build the understanding here in 5th grade. So I'm not going to show you any more. I do have a couple others, so we'll skip the slides so you'll see them. We're not going to look at them. But again, the takeaway I hope you're seeing, and I want you to take this further, even if you're not like a math person at heart, you're supporting all of the teachers in your school, which includes the math teachers. And so as an admin, as a coach, going into the classrooms, we had the conversation around fractions. So hopefully you can anticipate a little. If you walk into a 4th grade classroom and they're working with fractions, we know what kinds of things 4th graders are doing with fractions, right? They're comparing with unlike numerators and denominators and what those instructional implications are. They're adding and subtracting, but with like denominators. And so what those instructional implications are. And I would challenge you as a team, go further, right? Have these kinds of conversations with whole numbers. What are 3rd graders doing with whole numbers, thinking about the operations? What are 4th graders doing? What are 5th graders doing? How is that different? And what are those instructional implications? So that when you walk in, maybe you don't know right away if they're aligned to the exact benchmark, but you know if they're fitting into that systematic progression that's supporting all the grade levels, not just what they're doing on that one day. Right? Does that kind of make sense? All right, so I'll show you this one just to complete the picture with fractions. I'm just going to talk through it. What ends up happening in this question, in this last part, we're dividing fractions. We're dividing two things that are fractions. And this actually falls into 6th grade. It's not a fraction benchmark because the fraction strand only goes through 5th grade. After 5th grade, anything with fractions just goes into the number sense and operations. But there is also a fraction division benchmark in 4th grade. But kind of like with multiplication, they start with fractions and whole numbers in 4th grade, and then they multiply fractions and fractions in 5th grade. The same thing happens with division. In 5th grade, they divide fractions and whole numbers. In 6th grade, they divide fractions and fractions. And so just kind of completing the picture of the things we do with fractions, comparing, adding, subtracting, multiplying, dividing, and where all that fits in sort of the 3rd through 6th grade spectrum. Okay? Kind of make sense? All right. If y'all want to take a second to kind of reset, I know you had the standards books out. If you want to close those, mark those, set them to the side, and we'll stop talking about math for a little bit now, I promise.